Hi, my name is Justine Harkness, and in this video, we'll look at how to graph the potential energy as two charges move relative to each other. Potential energy is essentially an energy of position, and it's highest for charges whenever those charges are unhappy. So here, the signs of those charges will be important. If we have like charges, say a positive charge and a positive charge, those charges will repel each other. They're essentially like mortal enemies. So if you put them very close together, they're going to start fighting. There's going to be a lot of unhappiness overall. So you'll have a lot of potential energy when your like charges are close together. On the other hand, opposite charges, say a positive and a negative, are more like Romeo and Juliet. They really want to be together. So if we keep them far apart, they're going to be very sad. And if they are unhappy, remember that means that we will have a lot of potential energy. So in general, potential energy will be highest when like charges are close together. And it will be highest also when opposite charges are far apart. But what if our two charges were separated by an infinite distance? So essentially our two mortal enemies, our two like charges, would never see each other. Our opposite charges, our Romeo and Juliet, would also never see each other. So one charge would not know of the existence of the other. So at an infinite distance, as our distance approaches infinity, the force approaches zero, so our energy also approaches zero. So we say at infinite distance, there is zero potential energy. And let's think about how that energy changes as the distance changes. If we have like charges, say our positive charge and our positive charge, as we move those two charges closer together, we will see an increase in the potential energy. So for like charges, our energy is always positive. On the other hand, if we have a positive charge and a negative charge, and we move those charges closer together, as the distance between them decreases, so does the potential energy. So for opposite charges or unlike charges, the potential energy is always negative. Let's look at how the energy changes as we change the distance on a graph. In this question, we need to graph the energy versus separation distance of charges as they are moved. Now let's think about two positive charges that are placed near each other that are able to move apart. If we have two charges that are both positive, we are dealing essentially with like charges. So let's first get our graph set up. Here on our x-axis, we're looking at distance. And then, of course, on our y-axis, we are plotting the energy, of course, the potential energy. Now, if we're placing these two charges very close to each other, they will start with a lot of potential energy. However, as we start to move them apart, their potential energy is going to go down, and it will approach zero as we approach an infinite distance. So if we essentially connect these dots, we'll see that as our distance increases, our potential energy decreases, and it will be approaching zero. But let's look at what would happen if we had a positive charge and a negative charge. Now here we have opposite charges. So let's consider our graph. Here we're dealing with energy versus distance. And when we have two opposite charges that are starting close together, they're not going to have very much energy. Opposite charges like being close together. So their energy would be at a minimum. And as we start to pull them apart, our energy is going to get higher and higher. So we'll be increasing the potential energy as we separate our two charges. And notice, as before, as we increase the distance, we will still be approaching zero. Since at an infinite distance, the potential energy between both like charges and opposite charges will be approaching zero. So now you should feel more comfortable graphing the change in potential energy as we move charges either towards or away from each other.